Here we have a combination problem where we're given a reaction. We have this alkene plus HBr, and we want to predict the product, draw the mechanism, and draw the energy diagram for it. And you're given one note here that the first step is the rate determining step. And this is something you have to be given because the rate limiting step has to be found through an experiment. There's no way to look at a reaction and know that. And another thing to keep in mind as you work through these reactions is that you have a carbocation intermediate. Carbocations can rearrange. So it's not good enough just to memorize how HBr will add across this double bond. You really want to always draw out the mechanism to check for carbocation rearrangement, otherwise you might miss it. So let's start by doing our first step, which is just the proton transfer. We start at the double bond, draw an arrow to the proton, and lose bromide as the leaving group, and draw the intermediate that you get. So we're going to end up putting the hydrogen right here. I'm going to draw that in gray, and I probably won't include it in the next step. I'll just leave it implied. And then the carbocation goes right here. So again, this is the proton transfer. And even though we don't use it in this particular step, it's a good idea to go ahead and draw the bromide ion. Now, anytime you have a carbocation intermediate, bells should go off in your head to think about carbocation rearrangement. And in this case, we have a secondary carbocation. But if you take one of these methyl groups on the neighboring carbon and shift it over in a methyl shift, you'll end up with a tertiary carbocation. So that is going to happen. So the product for this, now we just have two methyl groups on this carbon. The other one shifted to this position, and my positive charge will be right here. And I'm not drawing this hydrogen in, but we know it's still right there. So we've gone from a secondary cation to a tertiary cation, which is more stable. And I'll just put a note here for you. When you have a carbocation, check for rearrangement. Don't forget about that. So now we have our most stable carbocation that we're going to be able to get here. So we're ready for the final step. You still have the bromide floating around in your solution. So that can come in as a nucleophile. And since I don't have the lone pairs drawn on the bromide, I'll just use my negative charge as kind of the surrogate for a lone pair and draw an arrow from it to the positively charged carbon. And this is known as a nucleophilic attack. When we do that, we get our product. So the last part is to draw the energy diagram or the reaction coordinate diagram. To do that, let's go ahead and label our species. We have a starting material and a product. Then we have intermediate 1 and intermediate 2. So I'm going to draw my x and y axis for the reaction coordinate. Now that we have that, we need to plot our different species. So I always like to start by just putting the starting material on my coordinate to give me a starting point. And let's just throw it in there right here. Then we'll put in our product, and this reaction works. If the reaction works, the product's generally lower in energy than the starting material. So put it at the end of the reaction. I'll put it down here, lower than the starting material. Now we need to put our two intermediates on the coordinate. Well, first, make sure your intermediates are higher than your starting material or your product. Just think about an imaginary line running right here, and your intermediates should not be below that line. So now when we put the intermediates in, we need them to be above that line. So let's put in intermediate 1 somewhere above that line. Intermediate 1 comes after the starting material. I'll put it right here. And then we need to put in intermediate 2. You have the knowledge to know where to put it relative to the other things. It should definitely be above this line, but intermediate 2 is more stable than intermediate 1. Why is that? Well, remember we looked at the carbocations. Intermediate 2 is a tertiary carbocation. Intermediate 1 is a secondary carbocation. So let's put intermediate 2 here just a bit below intermediate 1. All right, so now we have everything we need as far as our species on the coordinate diagram. Now we need to draw our lines connecting them and our transition states. And you should have a transition state between each step. We were told that the first step is the rate determining step. So that's going to be our tallest hump. So draw a big hump right here. There's the transition state for this step, and that's our rate determining step. No other hump should be taller than that one. Now we'll draw one to go from intermediate 1 to intermediate 2. And then we'll draw one from intermediate 2 to the product. This one, it really doesn't matter if you draw it lower or higher than this one. Most importantly, it just can't be higher than the rate determining step.